Carmen. You guys need to take out the series test that you worked on this weekend. Eileen, Giselle, Celeste, and Lewis, and Mike. All right, homework. If you could put last night's homework in the middle of the table, that was partial fraction decomposition. Hopefully. Are we all feeling like that was a pretty good experience? Sorry. I know we didn't spend a lot of time on partial fraction decomposition. That's because we shouldn't have to spend a lot of time on partial fraction decomposition. It is very much a skills kind of thing. And it's like a multiple choice question. Maybe showing up on the free response as well. But this should be the kind of thing that you guys are like, we're good, we're quick, we're in and we're out. Free response reviews happening tonight from 1:30 to 3:30. David, Polynomial, and Giselle Lewis, I've already talked to you guys. Tonight's homework, because you are staying, you get a 100. Now that requires you to stay from 1:30 to 3:30, work from 1:30 to 3:30, not fall asleep between 1:30 and 3:30, and laugh at all my jokes from 1:30 to 3:30. If you know, don't start laughing early thinking it's extra credit. That's just sad. You're too smart for that. Okay. What we are going to do is we're going to focus on the free response part of the series test that you guys did this weekend. Scores were good. And actually this was very happy, surprise, that you all outperformed last year's class on the series test by a lot. Sorry, Nathan, Brian, Lucio, Victoria, whoever else may have been there. Good times, good times. Roger, oh my God, I can't believe I forgot somebody else. I'm going to have to. Anthony, you guys just got your butts whooped. You all did well. You know why? I get better. That's true, I do. All right. So here's the thing, though. You all did well, but there are some issues that we need to address. And I'm just going to go through all the questions. Feel free if you want to use a separate sheet of paper for the feedback. If you want to just write on your test, nobody's test grade is going to change at this point. I just want to go over high-level issues that came up. Okay. So I'm on question number 13 part A. All right, what happens in 13 part A? You've got a series, they gave you the expansion, they said use the ratio test. Most people were fine, limit as n approaches infinity, a sub n plus 1 over a sub n. They did some stuff. At the end, they get to this. They say it's less than 1. Excellent. You got a point for the setup. You got a point for getting over here. And then some of you, I withheld the point. Because what I saw a lot was, oh, that means that the absolute value of x is less than 1/3. True. True. Doesn't answer the question. What did they ask for? They asked for the radius. You have to tell them it's the radius. So some people said r equals 1/3. That's fine. Done. Get out. Not let get out. You. Okay. Radius of convergence is 1/3. This is the kid that just likes their handwriting. Okay. No need to write this. At least. Stephen, are you filming?
Yeah.
Okay. Good. I don't know if Giselle was saying wake up, son. Is everybody okay? This is different than stopping here. Here what you're telling me is you're telling me information that involves the radius of convergence, but here you're being explicit and you're saying, hey, College Board, I know that the radius is 1/3. Stopping here, I held the point back. Getting all the way over here, you get the point. All right, part B, write the first 4 non-zero terms of the Maclaurin series for f prime of x. For the most part, things were good here. Things were good on the first part anyway. So we know from the beginning that f is x minus 3/2 x squared plus 3x cubed. Now there's some more stuff. There's -3 to the n minus 1 over n. There's an x to the n and the plus ... Write the first 4 non-zero terms. Most people were like, hey, f prime is 1, minus 3x plus 9x squared. Some people I think, get themselves a little turned around. It did say 4, right? A lot of folks get a little bit turned around. They're like, what's the next term? Either you recognize a pattern or you use your generator to come up with the term that you need over here, right? That would be what, n equals 4. And so some people said negative 3 to the 4 minus 1. Well, gosh, that's negative 27 over 4x to the 4th. The derivative is negative 27x cubed. That's a way you could get around it. Other people said, hey, I see a pattern here. I see a pattern with the signs, negative, positive, negative, positive. I see a pattern with the exponents. I see a pattern with the coefficients. Everybody good with the first 4? And here's where we run into a problem. For anybody who wrote this, I had to withhold a point. Anybody see why? Why can you not get full credit here? Look at what I wrote on the board. Think like a College Board grader. What are they going to see that they don't like color on?
You're going to finish with plus dot dot dot, plus the equation and then dot dot dot.
What you're saying if you stop here is that f prime, the derivative, is this guy over here. That's not true. These aren't equal. What this is are the first 4 terms of your Taylor series expansion for f prime of x. There's a difference here. So I wouldn't even say f prime is approximately. You could just say like first 4 terms. Right? That's what they wanted. Here are the first 4 terms. Another notation that we have for this is this P4. Right? P4 is 1 minus 3x plus 9x squared minus 27x cubed. Love it. Life is good. No problems. No problems. And then we get to the second part, and I saw a lot of this. Using the Maclaurin series for f prime, the derivative of f, now express f prime as a rational function. And I saw really like a lot of those. Like, you want me to do what? F prime has this form. F prime is 1 minus 3x plus 9x squared minus 27x cubed plus dot dot dot. But they want an equation for f prime. There's something else happening here, and I think most people didn't see it, and we hadn't had a lot of conversations about this. But there's something I hoped you'd recognize about those first 4 terms and the kind of series that they make. 1, negative 3x, 9x squared, negative 27x cubed. There's something happening here with these terms. They're alternating for sure. There's a common ratio. Common ratio. Think about dividing this guy by the one before, this guy by the one before. To move from one term to the next requires multiplying by negative 3x, multiply by negative 3x, multiply by negative 3x. What kind of series? Geometric. And because it's geometric, and we're being asked to combine all the terms of a geometric series, there's a formula that we know, right? If you have a geometric series, well, how does it work for geometric? It's the first term, not necessarily 1, in this case 1. It's going to be 1 divided by 1 minus your common ratio, which is that. So 1 over 1 plus 3x. That's what f prime is equal to. F prime is 1 divided by 1 plus 3x. Not a lot of folks getting the point here. A couple of y'all did. Not a lot, and kind of makes sense. All the friends okay? All right. Part C, right? The first 4 non-zero terms for e to the x. Oh, thank goodness. E to the x. 1 plus x squared over 2 factorial, x cubed over 3 factorial. Those are the first 4 terms. And there's a problem.
Plus. Or.
It's the same problem that we just talked about. what you're saying, if this is what you write, e to the x equals 1 plus x squared over 2 factorial plus x cubed over 3 factorial, stop. Stopping is the problem. You would either need to write the plus dot dot dot, or you'd want to say the first 4 terms are here, stop. Everybody okay with that? Alright, and then things get a little crazy. Use the Maclaurin series for e to the x to write the third degree Taylor polynomial for g. Well, g is supposed to be e to the x times f of x. We know that e to the x is 1 plus x squared over 2 factorial, x cubed over 3 factorial, dot dot dot. F of x, they tell us in the beginning, is this x minus 3/2 x squared, where are we, 3x cubed, dot dot dot. E to the x times f of x is going to be this guy times this guy. Everybody's okay with that part? What do we need? Stephen, what do we need here?
You need to multiply them by each other by using the box.
So I've got to multiply this infinite degree polynomial with this infinite degree polynomial. Oh my God, I'm never going to get it done.
No, you can either use the first 4 terms for e of x and the 3 terms. For,
Right. If my goal is to generate the degree 3 Taylor polynomial, I need to multiply out any of the terms that are going to give me something degree 3 or less. So just have a quick conversation with someone in here. You need to take attendance. What multiplication do you actually have to do out here? Identify the terms. Maybe you want to write them out. Don't simplify. Alright, so if we're going to get degree 3, the 1 has to get multiplied by the 3 terms. What else do we have to multiply? Any other multiplication that's going to happen here? The 1 gets distributed to the x, the 3/2 x squared, and the 3x cubed. What else? Do we have to multiply the x with anything? Right, this is like a big multiplication problem. An infinite degree polynomial with an infinite degree polynomial. Your goal is to come up with a degree 3 Taylor polynomial. So degree 3 Taylor polynomial has constants, linear terms, quadratic terms, cubic terms. So what do we multiply the x by?
-3 over 2x squared.
Multiplying with the -3 over 2x squared for sure has to happen. But you also have to multiply the x with the x, because that's going to give you an x squared, which is going to show up in the degree 3 Taylor polynomial expansion. How about the x squared over 2 factorial? Does that get multiplied with anything in the second expression? Just with the x, right? Because if I multiply the x squared with this guy over here, degree 4, I'm out. That's not going to be involved. The x cubed over 3 factorial doesn't get multiplied with anything over here. There's no constant expression. And I would just multiply those out. I don't know that I would bother simplifying or doing anything crazy like that. Okay. Really, in question number 1, my thought was like, I think with the exception of this part on part B, a relatively kind question, a lot of what you guys were expecting, a lot of really good stuff happening, that there was just some really shaky notation with like, what are we saying things are equal to each other? You've got to look out for that. That's a place they're going to withhold points. All right, so on question number 14. Question number 14, not bad. Like A and B, both high scoring questions, and for the sake of time, I don't know unless there's anything specific somebody has a question about for A and B. I don't know that I have anything we need to talk about. So why don't you take a minute, look at that question, specifically look at A and B. If there's anything you're not sure about, let me know. Grab the homework pile over here. Okay, first four non-zero terms of the Taylor series for sine of x about x equals 0. Sine of x is your odd function, so x cubed over 3 factorial, x to the 5th over 5 factorial, x to the 7th over 7 factorial, and it alternates. Of course, we want to be careful. Sine of x isn't equal to that. But with the plus dot dot, now you get sine of x. And then they ask for what? Sine of x squared. So it's replacing all the x's with x squared and being really careful with your exponent rules. Plus dot dot dot, if you want to simplify, x squared minus x to the 6th, 3 factorial, x to the 10th, 5 factorial, x to the 14th, 7 factorial. I can't remember, was this 2 points or 3 points? 3 points? And I think for the most part, almost everybody in the room earned all 3 points on part A. Good. Part B, cosine. Cosine of x is an even function, so 1 minus x squared over 2 factorial, x to the 4th over 4, x to the 6th over 6, dot, 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 dot. That's the first 4 terms. Use this series and the series sine of x squared in part A to write the first 4 non-zero terms for f. Well, f is cosine of x plus the sine of x squared. The first 4 non-zero terms, I'm going to take stuff from cosine of x, I'm going to take stuff from sine of x squared, and I'm just going to put these together. So first 4 non-zero terms, I've got a 1, x squared minus x squared over 2 factorial. I don't know that you actually need to combine those, simplify those, do anything. I think you'd be okay with this. Anything else we need to include? We get this guy, we get this one. Anything else we need to correct? The x to the power of 4 over 4 factorial. So first term, you combine this together, this is the second term. Here's the third term, the fourth term. Fourth term is this guy here combined together with that guy there. So negative x to the 6th over 3 factorial, negative x to the 6th over 6 factorial. That's the degree 6 Taylor polynomial. It's the first 4 terms. That's all. Generally another high scoring question. Part C, what's the degree 6 Taylor polynomial, what's f6 of 0? f6 of 0, I saw a lot of people say, I know that this has to do with the x to the 6th, but then kind of blew it a little bit. What part of the x to the 6th does this represent? Well, this is the coefficient, but not completely. F to the 6th over 0, 6 derivative of f evaluated at 0 divided by 6 factorial is going to be equal to the coefficients. So negative 1 over 3 factorial minus 1 over 6 factorial. To get the 6 derivative at 0, you're going to multiply both sides by 6 factorial. And I think if all of that goes well, you get something like negative 121. Yeah.
Oh wait. Never mind.
Sure?
Yeah.
Everybody okay? All right. So A, B, C, high scoring. And then there was part D. Okay. And truly zero shame. Let P4 be the fourth degree Taylor polynomial for f about x equals 0. Okay. Using information from the graph of y, which is the absolute value of this guy up here, shown above, show that the absolute value of P4 evaluated at 1/4 minus the true value of the function at 1/4 has to be less than 1/3000. Good news, lots of good attempts. I'll use the word attempts. Lots of good attempts. I saw a lot of Lagrange. True. True. But here's the thing. What Lagrange says is that this guy here, and you've got to be so specific, is less than or equal to something very particular. According to Lagrange, what I saw a lot of was m, then there was a 5 factorial, and then there was this like 1/4 minus 0 to the 5th. Okay, but what's m? If you're going to go with this approach, and there's nothing wrong with this, you've got to be super specific. What's m? What does m mean for you? I want to check your notes on this. What's m? Polynomial, you okay over there? You look like you're having some really deep thoughts. What's the significance of m? It's the maximum. It's the maximum of what? And this is where it's way specific. It's the maximum of some function. Get the right function. What's the function? But you've got to be specific. This is the graph of the 5th derivative. In fact, what I need is the maximum of the absolute value. But not maximum everywhere, maximum on a very specific interval, and you have to mention the interval. The maximum where? Where's that maximum? We're approximating the value of the function at 1/4 using a polynomial that is centered at 0. What I need is the maximum on this interval, 0 to 1/4. You can't just say max of the function, because if it's max of the function, well, this function keeps going up forever. I need to zoom in specifically on the interval. Here's 0, here's 1/4. Do we know anything about the maximum? Right, on this particular interval, doesn't it have to be less than 40?
Yeah.
So I'd say, okay, so this is 40 divided by 4 factorial, 1/4 to the 5th. What I saw missing in a lot of places was this like definition of what the max was. If you want to use m, that's fine. And then I saw a lot of this. And maybe College Board is going to let you get away with this. A lot of people just said this has to be less than 1/3000 because this is what you're asking me to compare it to. I think they're going to look for something more here. I think you're actually going to have to do the simplification. So in terms of the simplification, before I make the comparison, I know I need that, but I'm not there yet. 5 factorial? What's 5 factorial?
1.
5 times 4 times 3 times 2 times 1. That's 120. So 40 over 120, 1/4 to the 5th. 40 over 120. They picked kind numbers for you. This is a third. Now 1/4 raised to the 5th power. Yes, you're going to have to do this. 1/4 times a 4th times a 4th times a 4th times a 4th. Here, let me help you out. The numerator's 1. 1/4 times 1/4 times 1/4 times 1/4 times 1/4, that's 1, yeah. 1 over 4 times 4, 16, times 4, 64, times 4, 256, times 4 is 1,024. If I multiply those two fractions, that's 1 over 3,072. That has to be less than 1 over 3,000. The denominator is bigger and the numerators are the same. The fact that this was a low-scoring question wasn't a super big surprise. Lagrange has not made a lot of friends in his world. That's why I think he died so early. All right, everybody mostly good? And then we get to question number 15. Question number 15, part A. Good news, most of you have figured out radius and interval of convergence. It was a 5-point question. Life is good. And then most of you got to part B and really had no idea what was going on. Understandable, this was meant to be the push. This was meant to be the, gosh, we've not done anything like any of this. What the heck are you supposed to do? Well, what they want you to show is you need to show that x times y prime minus y is equal to 4x squared over 1 plus 2x. Way back when we did this on a regular basis, differential equations, right? We'd say, like, here's a solution. Show that it's a solution. In order to show that this guy here, y equals f of x, is a solution, you've got to plug it in. Well, to plug it in, that means I need to know what y is. Well, y is f of x. What's y? Well, gosh, it's this guy over here. Let's write out the first couple of terms. Take a minute, right? Give me those first couple of terms.
4x squared.
If n's equal to 2, negative 1 squared is 1. 2x, the whole thing squared, is 4x squared. Divided by 2 minus 1, so we start off with 4x squared.
Minus 8 to the power, 8x to the power of 3 over 2.
Okay, and specifically our sum starts at 2. So this is what you get if n's equal to 2. This is what you get if n's equal to 3. Let's just do like 1 or 2 more just to make sure that we know what's going on. N equals 4. Negative 1 to the 4th is 1. 2x to the 4th is, what, 16x to the 4th over 3? And maybe one more, just for giggles. N equals 5. Negative 1 to the 5th is negative 1. 2x to the 5th is that negative 30. 2x to the 5th over 4. Simplify it if you want to negative 8x to the 5th plus stuff. That's why. That's what I'm going to plug in here. But I still need to figure out, what do I plug in for the x times y prime? Well, y prime, find the derivative. So take the derivative. Derivative of 4x squared, 8x, minus derivative of 8x cubed over 2. What is that? 24x squared over 2, 12x squared. Derivative here is 64x cubed over 3, minus, I think that's 40x to the 4th, and more stuff. College Board said that gets you a point. The fact that you found the series expansion for y prime, not too bad. I need to be able to pull all of the stuff together. So how about looking at x times y prime? Multiply everything through by x. 8x squared, you've got 12x cubed, what is it, 64x to the 4th over 3, 40x to the 5th, so on and so on. We're almost there. They give another point for that. We've got y prime, we've got x times y prime. What I need is xy prime minus y. This guy here minus y. 8x squared minus 4x squared has to be 4x squared, right? This guy minus that guy, 4x squared. Negative 12x cubed minus this guy over here. Maybe you want to simplify it, call it negative 4x cubed. Negative 12x cubed minus negative 4x cubed should be negative 8x cubed. 64 thirds x to the 4th minus 16 thirds x to the fourth is, what is that? 64 minus 16 is that 48 over 3x to the fourth, so that's 16 x to the fourth. Go a little bit further if you need to. Negative 40x to the fifth minus this guy here, stay with me for just 1 second, is negative 32x to the fifth. That's the left-hand side. Anybody notice anything about what's on the left-hand side? How would you ever show that that's equal to what's on the right-hand side? 4x squared, negative 8x cubed, positive 16x to the fourth, negative 32x to the fifth. There's a pattern here. It's geometric. It's geometric. Your radius, your common ratio is negative 2x. So the sum is going to be 4x squared divided by 1 minus negative 2x, which is this 4x squared over 1 plus 2x. I knew that one was going to be rough, but there were enough kind points in there, and you guys did really well picking up all the kind points. So tonight I'll see you guys at 1:30. You guys are going to be working a lot of problems with other students. I'll see you later.